Good afternoon, Year 10. So we're going through some sketching quadratics problems today. It's a fairly quick video, so you'll have to have your wits about you. There are three basic steps. The first one is to consider the shape of the quadratic. The second one is to find the X-intercepts for the graph you're drawing. And the third one is to find the Y-intercept of the graph you're drawing. Those are the key concepts, and we'll go through 4 examples showing how we do each of the steps. So we'll start with shape. Okay, for this first quadratic, we're looking for the number a, number in front of x squared. Now that's 1 in this case, and 1 is positive, and we're happy when we're positive. So we draw a big happy face. For this second quadratic, -2 is the value of a. -2 is negative, so it's sad. So we draw a big sad face. In this question, a is hidden. We have to expand the x squared term to find it. If we do that, we're going to get -6x squared. So a is -6, which is negative, and therefore sad. So bring on the sad face. And in our final example, a is +1 again, so we draw a happy face. Once we have the shape of the graph, we need to find the x-intercepts by making y equals 0 in the original equation and solving that equation. Now we've done solving quadratics recently, and that's what this turns into. We change our equation to make y equals 0, and in this case we can factorize. I've rushed through the factorization here, but you will need to remember what you're doing. And to solve, I make one bracket 0, which means I'd need x equals 3, or the other bracket 0, x equals -5. Draw your x-axis and mark those two numbers on in order that you would find them on the number line. Okay, so finding the x-intercepts for our second example, we make y equals 0 and we solve. So we write down our original equation with y replaced by 0, as you see here. Now it does factorize, so I am going to factorize, and it's a nasty factorization. I've got to take a negative factor out somewhere, I think, and as I do it, I'll remind you that this is something that you've done recently, and you'll need to practice if you're going to be good at sketching quadratics. So I get my two factors, and I make each equal to 0. So if I make the first one equal to 0, then x has to be 3, and the only value of x that makes the second bracket 0 is 1/2. I then put on my x numbers onto my x-axis, which I draw through my shape. Now if your equation is given to you already factorized, it's actually quite nice because you don't have to do this step. But I will show you in more detail how you solve a quadratic equation when it's factorized, especially something nasty like this. We set up the equation, one of the brackets equals 0, or the other bracket equals 0. And then you solve those little mini equations. And that's how you figure out what x is. And we are going to draw an x-axis and plot these two numbers on, remembering one is negative and one is positive. So it's the same starting point for this. We're making y equals 0, and we'll solve. This quadratic does not factorize. So one of the methods we can use is to use the quadratic formula. I'm copying it down on the screen now. And if I substitute my values of a, b, and c into that quadratic formula and press equals, I get -4 plus root 15 or -4 minus root 15. And if I press the SD button on my calculator, I get these in decimal form. They're both negative numbers, and it's important that I know whether they're negative or positive. I'm going to mark them on in decimal, but there's no reason I couldn't write those on in surd form. But if you ever struggle, use the quadratic formula to solve your to find your x-intercepts. Okay, for the y-intercept, we start by drawing the y-axis. We need to think where x equals 0 will be, because the y-axis will pass through that. And then we are going to use our equation, make x equals 0, so we can find out what y equals. Now if I substitute x equals 0 into my original equation, I get y equals minus 15. And that's what gets marked on as my y-intercept. Okay, for our second example, we're going to draw our y-axis on. Now you can see where x equals 0 is just to the left of a half, so I have to squeeze my y-axis onto the left-hand side. I'm going to substitute x equals 0 into my equation, minus 2 times 0 squared, plus 7 times 0, minus 3, and that gives me minus 3 as my final answer for y, and that minus 3 becomes my y-intercept. Okay, so this new example is the same idea. We draw a y-axis. 0 comes between minus 3 and 1.5. We make x equals 0 in our equation. Now, because we have it as a factorized form, we're putting 0 in the brackets. So 3 times positive 1 is positive 3. So positive 3 is my y-intercept. Once again, we start with the y-axis. It goes to the right of both negative numbers because that's where 0 will be on my x-axis. I substitute in x equals 0. Now we can get used to it by now that making all the x's 0 just leaves me with the value of c, which is positive 1, which we mark on to the y-intercept. Okay, after those examples, just a couple of special cases, and they involve step 2 in particular. If I give you this quadratic here, we can factorize it, and it would take you much longer than this to factorize, but you would get 2x minus 3 and 2x minus 3. Now the key here is that they both give you the same value of x, 3 over 2, or 1.5. So the same solution, that's what this special case deals with. How do we have a graph that crosses twice at the same point? Well, there we go. I've just drawn one. It just touches the x-axis at that point, and you can see the y-intercept would be that final number c, which is 9, so it all makes sense. That's the graph for this equation. Okay, the final special case I can demonstrate using this example. It doesn't factorize, so the first thing I'm going to do is to solve the equation of it being equal to 0 is use the quadratic formula. Now the problem with using this quadratic formula is if you substitute in a, b, and c using 2, 1, and 7 in the appropriate places, and I'm doing that now. If you type all that into your calculator, you're going to get math error appear. And the reason why you're getting math error appear is because you cannot do this calculation. If you work out what's under the square root, it comes out as minus 55, and it's impossible to square root a negative. So because of that reason, we can't find any x values to solve this quadratic. Now what that means is that the graph doesn't cross the x-axis at all. Well, what does that look like? It looks like this. We can still figure out the y-intercept, we can still figure out the shape, but it doesn't cross the x-axis, and so it looks like what you see on the screen. To quickly recap, if A is positive, you get a happy face. If A is negative, you get a sad face. You solve the quadratic equation to find the x-intercepts. It's the same as making y equals 0 and finding x. To find the y-intercepts, you're making x equals 0, and that will find the value of y, which will always be the same as the value of c in the original equation.